So this is the centrifugal fan experiment. It simulates an HVAC system where the flow restrictor here simulates resistance of a longer duct to fan-powered airflow. So you can open the flow restrictor further or close the flow restrictor at this end of the experiment. Now down here at the other end of the experiment, we have the fan driven by this motor where air enters at the other side here, and it's called a centrifugal fan because air is thrown to the outside of this enclosure via centrifugal force imparted by the impeller blades. Then the air travels down the wind tunnel to the flow restrictor at the other end. The system consists primarily of the fan, the motor that drives the fan, the wind tunnel, and the flow restrictor, as well as the instrumentation, which I'll talk about next. So as far as sensors, we have two thermocouples, one here at the inlet to the fan, one in the wind tunnel here, and then there are three pressure transducers. One here right after the fan to measure the static pressure in the wind tunnel. One down here at the pitot tube, again measuring static pressure. And finally, the differential pressure drop across the pitot tube. Additionally, we have over here, we have a load cell that measures the force from the moment arm of this dynamometer that cradles the motor. We have a magnetic pickup that measures the speed of the motor in revolutions per minute, and also a power cell that's enclosed back here measuring the power input to the motor. So when you take pressure measurements with the pitot tube, you can actually traverse the location of the pitot tube inside the wind tunnel by sliding this block up and down. Traverse locations are marked here with small numbers. We have traverse location 1, which is a slight offset from the top of the wind tunnel, and then all the way down to traverse location number 10, which again is at a slight offset from the bottom of the wind tunnel. You'll notice the traverse locations are not evenly spaced. That's because of the fact that we want to get the same area at each traverse location, same cross-sectional area. So you can also change the angle of this scale within the pitot tube, or I'm sorry, within the wind tunnel by loosening the apparatus here and then moving the whole apparatus, rotating it within the wind tunnel. So to start up the experiment, you'll use this control panel here. The first thing though that you want to do is make sure that the switch at the centrifugal fan breaker on the wall over there is turned on. You'll see it's actually labeled with some red writing that says centrifugal fan breaker. Once you're sure that that switch is on, you can then push the start button here. You'll hear a satisfying click, and then push the run button on the control panel. And you'll hear the motor start. Again, to shut down the experiment, just do the opposite. Push the stop button here. You can push the stop button there to immediately stop the motor. And while you're taking measurements, you'll want to make sure that the tachometer is turned on so that you can see the speed measurements of the motor. At this point, you would, once the experiment is running, you would then change the flow restrictor setting at the other end of the wind tunnel. So once the experiment is running and you are operating at a set point where you want to take data, you would come here to the Excel spreadsheet and click on the Do One Scan Now button. When you click that, numbers will begin populating these cells. Notice the pitot tube takes a while to read, and also the magnetic pickup takes a little bit to read. On the edge here of the spreadsheet, you have a diagram that explains how to traverse the wind tunnel with the pitot tube.